Hello, class. I wanted to share some information about how to use equations to solve market equilibrium between quantity supplied and quantity demanded. On the left-hand side of this screen, you should be able to see the two equations that are corresponding with the graph on the right. The graph on the right is our market graph with an upward sloping supply curve and a downward sloping demand curve. The supply equation is going to be denoted with the Q sub S before on the left-hand side of the equation before you see the 2500p, and the Q sub D or QD equation will be indicating the demand curve. Now, the supply curve is upward sloping, which is why it's going to have a positive number in front of that P value. That P stands for price, just like the Q stands for quantity. And the negative sign in front of the 2500p for the demand equation indicates the demand curve is downward sloping. The 3 million that is added to the QD equation indicates the intercept, which is the point in which quantity demand is at when price is 0. The reason why there's no number after quantity supplied is because quantity supplied will be 0 when the price is 0. And then the 2500 represents the slope of the respective supply and demand curves, which is 2500 for each of them. So that means that for every dollar that price increases by, quantity supplied will go up by 2500 units, whereas for every dollar that price goes up for quantity demanded, that will go down by 2500 units. In order to find a market equilibrium, which is what we're trying to determine here with supply and demand being combined together, is to find the point where quantity supplied is equal to quantity demanded. Remember that quantity supplied is a specific point on a respective supply curve, and quantity demanded is a respective point on the demand curve. As a result, it should make sense that the intersection point of these supply and demand curves will be that one point in which quantity supplied is equal to quantity demanded. So that is our market equilibrium point. The question is, what is that price? We want to know what this is, P star, our equilibrium price. We don't know what that is. We want to know what our equilibrium quantity is. We don't know what that is based on this graph because we don't have any numbers here. But we do have the equations. So the way in which we solve this is we are going to use some algebra with the equations that we have given to us. So let me take away these eraser marks so we can make sure that we solve this correctly. So in order to find the correct price and quantity that we need to know, we're going to set these equations equal to each other. So when quantity supplied is equal to quantity demanded, which is there, we know we're at our market equilibrium. So what we have to do is we have to take the right-hand side of these equations, so this part and this part, and set that equal to each other. The quantity supplied is 2500p, so that'll go here. Quantity demanded is negative 2500p plus 3 million, so that'll go here. And then we have to do a little bit of algebra. So in order to solve an unknown variable, which in this case is going to be our price, we need to isolate that price variable, that P, on one side of the equation and just have regular numbers on the other side of the equation. So we need to get that negative 2500p on the left-hand side of the equation. So the way we do that is, since it's negative, we're going to add 2500p to both sides because then it balances the equation out. So this will cancel. We add 2500p to this side, and then we have 5000p is equal to 3 million. Now that we've isolated all the p's to one side of the equation, all we have to do is get p down to just 1. So how we do that is we divide 5,000p by 5,000, and that'll give us just p. And if we divide 3 million by 5,000, these zeros will cancel out, and you're left with 3,000 divided by 5, which is going to give us our equilibrium price, which is $600. So this point right here will be $600. To find our quantity, what we're going to do is we're going to take that $600 and we're going to plug it back into the original equation. Which equation, you ask? Well, it doesn't matter at equilibrium. If you were trying to figure out what quantity supplied and quantity demanded were outside of equilibrium, then you would have to choose the appropriate equation. So if you're trying to find what quantity supplied would be at, say, $400, it's not at an equilibrium, so it's going to be a different quantity supplied than a quantity demanded. But in this case, because we're at equilibrium, the quantity demanded and the quantity supplied will be the same. And I'll show you here in a second. So we're trying to find QD. So we plug in negative 2,500 times 600, because that's our equilibrium price, and then add 3 million to that. So negative 2,500 times 600 is negative 1,500,000. You add that to 3 million, and you're left with positive 1,500,000. Which is going to be your equilibrium quantity. So that goes here. Now, we can verify this further by plugging it into the supply equation, which is just 2,500 times 600. Before we got 1.5 million, but negative because we had a negative sign in front of the 2,500, which makes sense that if we just omit the negative sign, that we would just be left with 1,500,000. And so we have correctly verified that 1.5 million or 1,500,000 is the correct number of units. So that is how you solve market equilibrium using equations. Now, you may, in subsequent problems, depending on what class you're taking, have a situation in which you need to find quantity supplied, quantity demanded, or price at a point that is not equilibrium. If that is relevant to you, then this is how you would go about that after I clean up my work here. So if equilibrium is all you're interested in, then you have everything that you need. But if there is a case in which, say, we wanted to know, let's say we have a price ceiling right here at $400, and we want to know what the actual quantity supplied would be versus the quantity demanded. Quantity supplied is actually going to determine your new quantity in terms of actual production and sales, because you need a one-to-one relationship. So even if there's high demand, the supply will dictate how much is actually going to be transacted. Just like if we had a price floor that was above equilibrium, it would determine what the demand curve would determine what the actual output is. So in this case, the supply curve is determining the actual output, but we can also identify the disparity between quantity supplied and quantity demanded at this $400 price. So again, we don't have any numbers on our graph, so we don't really know what the answer is. So in order for us to figure that out, all we have to do to find that, because remember, this is the supply curve here, we just have to plug $400 in to the equation. So when we do that, we should get 25 times 4, which is 100, plus 4 zeros, 0, 0, 0, 0, and you get 1 million as the quantity. So this is 1 million. If you plugged it into the demand equation, then you would get negative 2,500 times 400, plus 3 million. I'm going to shorthand it here. And that'll give you 1 million negative plus 3 million positive. So that'll give you 2 million as your quantity demanded. Now, again, because quantity demanded is higher than quantity supplied, this would be the actual output that would be transacted in the economy. Now, what if we wanted to find a price? Because we've been trying to find quantities by plugging prices into it. What if we were trying to find a price that wasn't equilibrium? Finding price is easy. If you find equilibrium, you set it equal to each other. But if you're just trying to find any old price, given a specific quantity, well, then you just kind of do things backwards. So the way this will work is as follows. You may be asked, what is the price that corresponds with here? We don't have numbers. So how do we figure out what is the price at that point where the demand curve crosses the y-axis or the price axis? Well, first off, we know that this is the demand curve. So we know that this is the equation that we're going to need to use. But secondly, we also know that quantity at this specific point right here is also going to be 0. So knowing that this is the demand curve and that the quantity demanded at that point specifically is 0, all we have to do is plug 0 in here and solve for the price using good old algebra. So if we, again, isolate the p's to one side, we add 2500p. So this cancels. We add 2500p to this side. Apologies for the handwriting. So we end up with 2500p is equal to 3 million. We divide both sides by 2500. This cancels. And these two zeros cancel. So we're left with 30,000 divided by 25, which isn't as intuitive. But the reality is it ends up being $1,200. 25 times 12. Yeah, so it'll be $1,200. And so that means that this would be 1,200 right here. Problem solved. And then you could do the same thing for this one, but since it's crossing at the origin, you would know that that one's 0. But if you ever needed to, like let's say it was up here, and that was your supply curve, then you could plug into the relevant numbers. The equation would be different, but you would be able to solve the problem in the same way. So that's basically a lot of the things that you would have to do with equations. One other thing that you may have to calculate with equations potentially is something that's known as consumer or producer surplus. So the equation for consumer surplus at equilibrium is 1/2 P star, Q star times this price right here, which is going to be the price where quantity demanded is equal to 0. It's just the intercept minus your equilibrium price, which is this in this case. So we've already used the equations to find those numbers. You would set them equal to each other, solve for price to find this number. You would set this demand equation equal to 0 to find this number. And then the quantity would be found by plugging P star into the original equation to get Q star. We've already found all those numbers. So in this example, consumer surplus is going to be 1/2 times 1.5 million times the difference between 1,200 minus 600. So that's 600. This is 1.5 million, all divided by 2. So you end up with, I believe it's $450 million. And the reason why that's the case is this is 900 million divided by 2. And then you would you could find producer surplus or deadweight loss using corresponding equations that you'll learn in the course if this is relevant to what you need to know. So I hope that gives you a little bit of a overview of using equations to solve equilibrium. And I wish you the best of luck on your assignments.